So a more intuitive proof of the Kaprekar. I'm not sure about the pronunciation. As an Indian mathematician who found this clever trick. Well, it's a pattern that he found. Just try to show a way you might prove that it's the case. So let's start here. Let's make this a little bit bigger. All right. So it's Kaprekar constant. It's a 6174 number. So let me show you what we have to do. Basically, we choose any 4 digits with whole numbers, and then we exclude the set of numbers like these 4 digits with the same number. Then we arrange the number from largest to smallest, okay? And then we do the same number and reverse it from largest to smallest, and the other one's from smallest to largest. And then we subtract them, and we do it in such a way where we'll finally come to a fixed point, a number, which is 6174. So the first thing of interest is what happens when you do it with 6174. It's a repeated fixed point, because if you take 6174, you see right here, I already, well, you can see that I already have this number. So I reset it, the largest number first, 7641. Then I'll subtract 1467. Then you got, there it is again. Isn't that weird? And you can do that forever. Okay. So what we have is that we have a way to put it into equation. Now, if you take a look over here, let's see if I can actually, yeah, let me see if I can put it right here. And maybe I can just do right here. And let me see if I can do something like that, so that we know where we're at when I'm reading. So let's see. So I was talking about this guy. And I don't know why it's not working. Okay. There it is. So here it is. I was talking about this guy here. And then I subtract that, and I already got the famous Kaprekar number. So now let's take a look at the kind of units here. We've got the ones, the tens, and then we have the 100 and 1000. So when I talk about the ones unit, that's right here. Right, so that would be, let's call it, well, if you call it A, B, C, D, right, where this 4 would be like the D. Well, you can see that I'm going to have, so first of all, look right here, C minus B is less than 0, right? Because the way we've organized them is in a way that, I'll have to put it here, that, let's show that, let me just write it down here. And so what we can say is that the numbers are going to be 0 will be right, so that's going to be 0, and it's going to be greater than, right, and that's going to have A. So we have A is going to be, and that's going to be bigger than B, and then C, and then D. Right, and that's how we set it up, so that if I look at the ones unit, so I'm going to have, that's, if I take, for example, 1 right here and I subtract 7, well, I'm going to have to borrow. So whatever D is, so let's say here's D, you see it, and then minus A. So that's the ones unit, right? So then I have, so D, there it is. And I have to borrow 1 from here, you see it? So when I borrow it, let me go back to here. When I borrow it, maybe I can go here. So this is what this equation's about, see it? It's going to be D minus A. So D, and then we borrow 10, right? And then minus A, see it here? Now, for C, this is capital C, by the way, as opposed to little c. we can see that we have to take A, right? We know that A is bigger than D. Okay, so I have that. And now, so we can see that right here we have C minus B. Okay, so then I have this, well, I'll show you in a second, 9 minus B plus C. And the reason we do that is because over here, you can see that I have, there's C is actually written like this, where we're in the 10 columns, minus what? Minus B minus C. Now, I wrote it like that because we know that B is greater than C, and so it's negative, so I got a negative there. So then I have that one that we took away when we borrowed it for the ones unit, and that's the tens unit. And minus 1 plus 10 gives me the 9. Okay, so now we're going to borrow one from the hundreds unit, and so that's just B minus C, and that's okay because B is greater than C. And then I subtract borrow 1, and then so I subtract the 1, and then the last thing is the simplest of all. It's just A minus D. Do you see? But that's the key to solving this problem, really. And then so what we got is you can see here we have A, capital A is little a minus D, and D is little a plus D plus A. So here you can see there are two equations, two unknowns, and then for the other equation we have B and C. So B, remember we said was the B minus C minus 1, right? And then C was the 9. So okay, so now this also has two equations and two unknowns. Now we have to solve, and the solution involves finding A, B, and D such that the order is consistent with A, B, C, and D in some possible order. Now let's see if I can make sense of that. So for possible solutions, there are 4 factorial, meaning how many ways can you actually distribute or combine something like this, where we have a combination. So if I got A, B, C, D, and how many ways can I organize them? Well, it's 4 factorial, right? Which means 4 times 3 times 2 times 1, right? So there's 2, 12, so there are 24, as you can see. Let me go over here. There are 24 of them. Now, you could try all 24 combinations and just muscle your way through it. But we might be able to find a little easier way to take a look at it. So you can do what we call the brunt force, right? Because that's just trying all some combinations. But there are some hints that are going to help us. We know we have 2 sets of 2 equations and 2 unknowns. So we're going to have AD and BC. And so I'm going to set AD either to little a and little d. So if I do that, I'm gonna have a problem here, because I have, okay, I'll let capital A will be A, but A minus D is little a, so then that says that D is equal to 0. So I can see that if A is not equal to D and D is equal to A, then A comes out to be equal to 10 in this case. So A is equal to D, and D is equal to A minus D and 2D. So if you solve that, you can see whatever A is divided by 2 will be equal to D. Well, this shows that we cannot, that AD cannot be using any of these 2. So finally what we come to conclusion is that we have AD, right, that can be solutions either, cannot be solutions AD or BA, right? AD must have possible solutions of what's remaining, BC or CB, right? You can do the same thing and with the other one, showing the idea for BC. See it? So AD can take on values. The solutions must be either BC or CB. Now, A cannot equal 0. That says there. So because A cannot equal 0. So it looks like that this would have to be a possible solution set, B and C. And you can show it again with BC that it cannot be little b and little c. It's going to either be this one or this one. And so A is not equal to D is what it's saying. Because A is not equal to D. So what we got left is that the solutions for BC must be assigned DA, and the ones for AB must be assigned BC. Okay, so I'll show you how that comes in. Now we have to have a system of equations that actually solves for those numbers such that it'll always come out to be 6174. Okay, so what I'm saying, if I let A equals B and D equals C and C little a, so BC can be equal, so we have, let's say, capital B here is equal to D. You can see it here, from here to here. And then capital C, you see it here, would be equal to the little a. And the reason that that's because BC, right? Is it going to be, B's going to be tied with a D and C is going to be tied with the A. You see that? And up here, then A is going to be tied to the B and D is going to be tied to C. Now, if that's the case, then we can start trying to solve this system of equations. Because we've signed we're hoping that we can show that A is going to be, and A, B, C, D will end up being 6174. So I take the original equations, remember, that I had for the ones and then the tens, right? And I put it in what's called a standard form. Standard form means that you have the variables on one side and the constants on the other. So here I have C equals 10 plus D minus A. Okay, and so I'm just going to take the 10 over and bring it over. So now I have A. See what I have of A, right? Plus 0 B, because there is no B, plus C minus a D. I just rewrote that first equation. The second equation was A is equal to 9 plus C by B. That's for the tens unit, remember? So I picked the 9 by itself, and I have A plus B minus C equals 0C. See that? And then I'm going to go here, and then the next question is, well, the next equation for the hundreds unit, 110, 100, yeah, is this one. So that's going to be D equals B minus C. So putting that in order, I have a 0A, I have a minus B, because I bring it over, and then I have a plus C and a plus D equals minus 1. So that's okay. And then for the thousandths position, I have, what we showed before right here. A is equal to, so what we're going to do now is say that B, well, that's the 100th unit, is A minus D. And if I solve for that, it's equal to 0 here. And I have an A, and I have a B, and I have a 0, and I have a D. So now we're going to set up a system of equations. So looking at that red line, you can see that A, the coefficient in front of A is a 1, 0, 1, 1. So if you look right here, I have my first guy here. It looks like it's going to be this guy right here. I put him in here. See it? So that has a coefficient of minus 1, 1, 1. So I got minus 1, 1, 0, 1, 0. So that takes care of the ones unit. Okay. So that's the thousandths unit, sorry. And then so now let's get to the next equation. The the one that's going to be equal to 0. Okay, that's equal to 0. And then the next one is going to be the one with the -1. That's going to go here. You can see that that will go here. Let me pick this. Yeah, so I got it here. So now if I take this one, notice that this is equal to -1 here. I don't know if you can see that highlight. Anyway, that is 0, right? So I have 0, -1, 1, 1, -1. Right, and then I have 1, 0, 1, -1 is 10. Right, that's going to be this guy here. See it? The very first, the top guy. So that's a 1, 0, 1, -1 equals 10. And then finally the 9. So I have 1 here, 1 in front of there, a -1. So what I got is the fourth one would be 1, 1, -1, 0, 9. Okay? So that's just a system of equations, and we hope that we can show what the values of, capital A are going to be B, C, and D. So what I did in this first row is I multiplied the first row by 1. So I just rewrote it in red. And then I added to the second, to the third and fourth row. When I did that, the third row becomes 0, 1, 1, 0 right here, right? And that becomes that. And now I'm going to take the second row. I'm just adding zeros below the main diagonal. So now I take this times 1, and I'm going to add it to this guy here, this guy here. And when I do that, the one you're using to add, it doesn't change. So now I have, and then I'm going to add them up. So now over here, let me see. That didn't come out very well. So then I took this and added it in, and finally I get it down to right about here. See it? And so that's okay, because now I have this guy here. You see, let me put it in red. Right, I have this guy. So after I whittle it down, you can see that here is one coefficient and one solution. So then I have -5 equals that. So we're going to say that D equals 1. Okay, and if D equals 1, then I can backstep it here, right, and put C, and then I'll put 1 for D, and I get 7. So what I get here is that when I do that, I got 7, and then I subtract 3. So here I got C equals 4. Okay, and then over here, for the next one, I have, well, now I know what C is, and I know what D is. So if I go to this one, I have A minus B plus B 0, but I know what B is and D. C is 4, so I know what C is 4 and D is 1. So let's see. Okay, so now when I want to solve for B right here, so I got C. B is easy enough because I got minus B plus C equals D, but we know already what C and D is. So C is 4, D is 1, and if you subtract that, you can see that you're going to have is equal to -1, right? So this is 5, so you go over here, so minus B equals, so now we know what B is. And you do it to the fourth guy, okay? And here we got minus A plus B plus D, but we know what B and D are now. No, we know what A and, no, we don't know what A is, yeah, so we know what B is, and so we got C, and here I got D. D equals 1, right? So then I put 6 plus 1 is 7 and take it around, so now I got this as an answer. So if we let A equal little b, and little b is equal to 6, and then b, which is equal to little d, minus 1, equals to 1, and that's what we wanted to show, this number 6174. And you can really try it with any number. You can see it works out pretty good. I mean, I did it with the repeating fraction, but let's try one here while you're watching. See if we can do it right. Okay, so I'm gonna pick. Let's just pick a number there. It says sometimes you might have to keep repeating the process. So let's say I pick 7, 3, 1, 2. I have no idea. I just top of my head. So so now let's see if I can work that. So first I'm going to put it in from largest to smallest. So that's be 7, 3, 2, 1. You see that? And now I'm going to subtract the reverse order where I put from smallest to biggest. So I got 1, 2. Oh, wait a minute, I did that wrong. I already wrote it in order. Let me change that. That was a kind of a. It was already in order. That was silly. Okay, so let's try it again. 1, 7, 3, and 4. Okay, now let's put it from biggest to smallest. I'll go doing this way. I'll put that as 7, 4, 3, 1, and then I'll subtract it from the opposite, going from smallest to biggest. So that'd be 1, 3, 4, 7. You see it? So this is where we're borrowing. So that's 11, right? So that'd be 4, and that would be, we'd borrow one. That's 2, but that's 12. So this would be 8. Is that right? So I borrowed one. That's 12, and 4 minus. And then I'm going to take 4 away from 12, so it's going to be 8, right? And then over here I have 4 minus 3, right? So 4 minus 3 would be 1. And then this is 6. That's pretty close. See if I got that right. 11 minus 7 is 4. And I'm trying to set 6, 1, 7, 4. It's almost there. What's going on here? So that's 11. 7 is 4. And that's 12. 12 minus 4 is 8. It's not quite right. So let's see what happens now. I got 6, 1, 8, 4. And I want to put that in order of from biggest to smallest. So I got 8. This is 8. 8, 4, 6, 1. Then I'll change the order. 1, 4, 6, 8. Okay, let's try that again. So that's 11. That would be 3, right? That's 5. That would be 9. That would be 3, 13. So that would be 9, right? And then that's 8 minus 1 would be 7. So let's do it again with that. So now I'm going to take 9, 9, 7, 3. And that's the order that's biggest to smallest. And then I'm going to do a reverse. I'll have 3, 7, 9, 9. So I got 13, right? Because I'm going to borrow one from there. So that makes that 13. And so I have to have a 4 here. Yeah. And then that's 17. 17 minus 9. So 17 minus 9. No. 16 minus 9. Because I borrowed one. 16 minus 9, right? So that's going to be 7. And then 9 minus 7. Oh, I borrowed one, right? So that's 8. So that's 1. And then that's 6 times 3. 3. That's 6. And there it is. It worked. It took 3 steps. I hope that helped. Thanks.